Hi everyone, we are going to talk about Transpiler, and so we're going to talk about Transpilers for unlegacize your legacy code. So the first thing that I would like to do is to explain what I mean by legacy code, because I don't know about you, but I always get confused by the term legacy code. I never actually understood what they meant. So my interpretation of legacy code in the context of this presentation is this. Let's suppose that you have a desktop application written in Visual Basic 6, for example, because, for example, you use it to manage your warehouse. And you really like the logic that is contained in this application. You're just unhappy about the fact that this is a desktop application in Visual Basic and not a web application in TypeScript, for example. Or perhaps you're writing some some data processing code for risk analysis, and you have this code in SAS, and the code is correct, but the problem is it's written in SAS, and you would like to have the same logic, but in Python and perhaps using Spark. Or maybe you have some code written in one of those old languages that used to run on proprietary IBM machines, like COBOL, RPG, PL1, and you would like the very same logic, but written in a language that you can package and put on some cheap Linux box that you can rent from the cloud. So, in this sense, legacy code is code that expresses something that is valuable, but the accidental problem is that it's expressed in a language that makes your life uncomfortable or more uncomfortable than it has to be. So we are going to fix that by unlegacize your valuable code. And I know that legacy code is not the most exciting of topic, but I would like to stress the fact that if you have legacy code, this is code that is valuable, because if it wasn't valuable, you would just throw it away. And it became legacy because it has been valuable for a very long time. So it produced value for your company for 15 years, 20, 30, or even more. So this is typically code that supports some fundamental business function in your organization, and there is a lot of value in it. We would like to preserve that value, and so that we can make the manager happy, but at the same time we would like to make the life of developers more enjoyable by allowing them to preserve the value and move to some other language that they can be more happy to work with. So this is why we are going to use transpilers. The agenda is this. We are going, first of all, to discuss why should someone consider moving to another language. Then we are going to see how. We are going to see some code running or crashing, but both of options are fun. And then we are going to understand how we can actually build a transpiler, and finally share some pointers that you can start from to build your own transpiler, so some open source components and some articles and resources. And by the way, if you have questions during the presentation, just ask them. Okay, so the first thing that we need to understand is why people are moving to another language. And when people contact us to ask us to help moving to another language, this is always what we start with. And there are two elements that are the most frequent elements of the complexive answer. The first one is cost. It's not surprising or exciting, but companies want to move to another language because in the current language they use, they're forced to use some hardware that is super expensive, or some software that has some license that is super expensive. There are nowadays other alternatives that are cheaper, and it's not surprising that companies like to save money. The second point is the fact that hiring is difficult. If you are looking for people familiar with one of those ancient languages, it's very difficult to find them. So at some point you would like maybe to expand your solution. You cannot because you don't find developers. At some point, perhaps you cannot even maintain the actual solution. And it's also very difficult to attract young, brilliant developers and propose to train them on one of those old languages, because there are a lot of options for developers. Okay, maybe at this very moment there are some problems with the job market, but normally there are a lot of options and people prefer to work with more modern languages. As a developer, when I started asking these questions, I was expecting people to tell me, we want to move to a new language because we are going to be way more productive, it's such a better ecosystem, we have better IDEs, a larger community, more libraries. Apparently, no one cares, and this is very saddening, so I want to share my sadness with you. I mean, a couple of companies say that as the third reason, but saving money, hiring are the real motivation behind this, and if developers suffer, no one cares. And so okay, now you have decided that you want to migrate, and the two main options, two main alternatives that you have is you just rewrite the thing in your favorite language, or you get a transpiler that does that for you. Now, I think that we as developers tend to be very optimist. So the natural instinct of a developer is, how difficult can it be? I take my favorite language, a framework that was released like 15 minutes ago, a couple of brilliant colleagues. I rewrite this old crap in 3 weeks. And, you know, there are some anecdotes that hint to the fact that developers tend to be over-optimistic. For example, you can look at how good we are with estimates. And there are things that let us, there are elements that make us think that perhaps this is not the case. And there are a few elements to consider. The first one is that you want to replace a system, and probably you were not aware when the original system was written, so you don't remember that maybe it took, at that time, way longer than they expected. It took maybe, 5 years to create the original system, and they had to put 20 developers on it. And it's very easy to underestimate the amount of effort that was put to evolve the system over the years. So maybe the system was created 20 years ago, and then for 20 years it was maintained, improved, new features were added, maybe also new bugs, but there was a lot of cumulative effort put into this system. So if you consider that, it's a bit unrealistic that you can replicate that in a matter of a couple of months, right? Also because you typically don't have requirements. So I never encountered a situation in which you want to replace an old system, someone open the drawer and tell you, okay, these are the requirements, you have just to implement those. This is the case maybe because people didn't write requirements, or they did write requirements, but they were stored on a floppy that was lost 10 years ago. Or maybe they wrote the original requirements, they still have them, but the system evolved over time and the requirements were not updated. So you don't have typically requirements, and also you often cannot talk with the guy who created the system because they left after realizing what they did, or they died, or they retired, or they just changed number, I don't know. You cannot talk to them. So the only solution left is actually looking at the original code. So you're a brilliant TypeScript developer, you want to replicate this software written in Visual Basic. And the only source of information is the software itself. but you don't understand Visual Basic. And so what do? You ask maybe some of the developers who created your system, if some of them are around, or maybe if some are sort of maintaining your system, you talk to them and you ask them to explain everything to you. But that's very cumbersome. And also, in some cases, they could realize that once they finish explaining to you how the old system works and you created a new system, they will be fired. This is not a great incentive for those people. I mean, this is not always the case. Sometimes they're retrained and so on, or sometimes they tell you they're going to be retrained. Because of all these problems, what happens is that typically recreating the system manually takes way longer than expected. In the meantime, there are changes in regulation, in business needs, and you need to evolve your system. And so now you're maintaining two systems, and this has become quite expensive. The two systems are diverging. At some point, after 2-3 years, the manager says, you know what, let's drop it. You keep saying that another couple of months you will be done, but you were saying that also 2 years ago, so you're not very credible at this stage. So in many cases, someone looking to creating a transpiler after this experience. And what is the transpiler? Is this application that just read the old code and produce the new code. And this is an example of a line of RPG code and the corresponding in Java. So now let's see some transpilers. Let's see the transpiler running, and then later we will see how it works, supposing it works. Okay, so if I say run this, now the system doesn't crash, will transpile and input this input file in this Java file. Now, let's look for a moment. This is terribly small, but maybe now it's more readable. Maybe I should say a couple of things about this fantastic language, which is RPG. RPG was born like in 1959, something like that. So among other peculiarities, it expects things to appear on a certain column. If I'm correct, the letter C, that indicates that this is a code line, so it contains statements, should be precisely at column 6. So if I add a space before, this doesn't compile. And so after that, the compiler say, okay, this is a statement. I will look for the statement in this position that could be column 26 or so. And then it looks for the operands on the left, on the right. So this is the hello world, and our transpiler produced this corresponding Java code. Now, in this case, the main part is very basic. We just instantiate the class and call the execute method, and the execute method contains our print line. Great. So now I will not rerun the transpiler for the other example given that I have already the file transpile, but we'll just look at the examples. This is a slightly more complex program where we have a variable that, of course, is a global variable like all variables in RPG. And this is a standalone variable, and this is a string of 8 characters. Then we have the plist that basically says that this program will receive from outside one parameter, the name. So if I invoke it from the command line, we receive it from the command line. If I invoke it from another RPG program, I will need to pass this parameter. And then we have our display statement with hello plus name. In Java, this becomes this. So we have a field to replace our global variable. And then we have, in the main, we just take the first parameter, assign it to name, and then in the execute method, we print hello name, and we can also see it running, or we can try. So it prints what is supposed to print, so hello Workdays Ticino. Now, this program is not exactly doing what the RPG program was doing. Why? Because the original RPG program was expecting a string to be up to 8 characters, and we are not enforcing that in the Java program. So this is a choice that we have made. So in a way, we could say that our program is more powerful because you are allowed to have very long names, and I have 3 names, so that's great for me. But in some other circumstances, that could be a problem. Perhaps we have programs that rely on that constriction. So, you know, when you're doing a transpilation, you have to consider these details and take a choice depending on the kind of application you're translating. And if you really wanted to create a system that behaves exactly as the original system, you will need to basically create the same language. So you need some adaptations, which could lead to all sorts of problems, of course. Now, we can also translate more complex programs like this one. So thank you to Franco who wrote this code. And I cannot manage to zoom it, but basically we have 5 global variables. In this case, they are integer variables. Some of them are initialized, some are not. In the code, we receive the number, the Fibonacci number to calculate. We call the Fibonacci subroutine, then we print result and the actual result. We have a subroutine that starts here and then here, which contain an assignment, a select, that is basically a sort of super switch. So the select says when number equals 0, assign 0 to result, when number equals 1, assign 1, otherwise do this 4. So we can also try to run this. Okay, perhaps I should have first shown the translation in Java, but you know, before of making it run. But this is how we translate it in Java. So you see, we decide to translate those numbers as long, and again, this is not exactly the same as the original language, because in the original language you have numbers, we specify that 8 integer digits. Here we have long with a different arithmetic, so not all results will be always the same. But this is the choice we made in this case. We could have used big integer, for example, or something else. Then one thing to consider is that we didn't have an equivalent of a select statement in Java, as far as I know. So we just translated as a series of if-else, while we had an equivalent for the for statement, and so we use the equivalent statement. Another small thing to notice is that in the original RPG code, you see this is an assignment, while this is a comparison. And they look the same, they use the same operator. They're different because of the context in which they're used. So this is one kind of peculiarity that you need to consider when performing the translation. Now, let me see how we're doing with the time. And we've seen the demo. Now, we have seen the Transpiler running, And now we can discuss a little bit on how it works internally. So what we want to do is take the original code, which is basically a big string, and translate it to another big string, that is the code in the target language. The problem is that we don't want to operate on a string level because it's extremely hard to work on the string level. Think about the operand that we have just seen, the equal sign indicating a comparison or an assignment depending on the context. If you're trying to solve this kind of problems using regular expressions, something like that, you could find that this is quite tricky. So we instead always build a representation of the information contained in the code that makes our life easier. And we call this data structure, this representation, abstract syntax tree. And now, once we have built this representation, in the past we used to directly use this representation, navigate it, and generate the target language. And this sort of works. But over the years, we change our approach, and now we use another element, another intermediate step before producing the final code. So we built an in-memory representation of the information that we want to put in the target language so that we can refine it little by little. And also we don't need to produce the target code in a linear way. Let's say that you are generating a Java file. If you generate a Java file starting from the beginning, okay, you need to define the package. That's easy. But then you need to define the imports. But you have not yet decided what code you want to generate below. That's quite difficult. While if you instead you have some representation that you can populate little by little, you can, for example, decide the code of the methods, then decide the imports, and only as the last step you can generate the code. You could then perhaps doing some optimization, removing maybe variables that you have translated but you are not using, doing all sorts of things little by little. And in general, this helps because otherwise it's very difficult to do everything in one step. So a few things that we've noticed is that it's very useful to have a powerful API to navigate the abstract syntax tree. It's useful to have this intermediate representation that you can refine little by little, and it's important to postpone code generation because once you go back to strings, it's extremely difficult to work with that and to do a little change. So you basically generate code when you're done and you don't need to do anything else. So to represent ASTs, what we have done is creating a set of libraries that are basically the same library I've written in 4 languages, and we call them Starlazo collectively. They are open source. The original one was written is written in Kotlin and is the most mature. Then we created basically the same one in TypeScript, in Python, and very recently we started the one in C#. So maturity become lower and lower as you read the slide. So let's see how we use this code, this library, and yeah, I have a breakpointer where I want. It's not super readable, but I hope you have very good eyes. And this is the core of our transpiler. And here we can see the same structure that we've seen in the slide. We start by reading the code of the file we want to translate that is stored in this variable. Then we parse it, and in this presentation we are not going to see how to write a parser, so sorry, but we don't have time for that. But what I want just to show you, is what we get in the abstract syntax tree. And I mean, supposing you can read that, basically I get an object that represents the information contained in the file that is called compilation unit, represent an RPG file. In this case, it contains one statement. In this particular example, I'm parsing the hello world, so we have just one statement. But if I were parsing, for example, the program calculating the Fibonacci code, here I will have all the data definitions. I would have the subroutine. I could see how the subroutine is named, all the statements inside the subroutine, and so on. So I have all the information as a series of Java objects that provide me all the APIs to find the information that I need. The next step is producing the Java EST. For now, we are going to see what I get in the Java EST. Later, we are going to see how we go from the RPG EST to the Java EST. In this particular case, I get this object representing the Java compilation unit. I can see that it contains one class declaration. The class is named hello world. It has two members. In this case, there are two methods, the execute method and the main method. Once I have done that, once I have completed the Java abstract syntax tree, as the last step, I can ask the system to print the Java abstract syntax tree into Java code so that I get my beautiful string that I can save on disk and compile and execute. Now, after parsing, that as we said is beyond the scope of this presentation, the two core activities that we do in a transpiler are the transformation from the RPG abstract syntax tree to the Java abstract syntax tree, and later the code generation. For the transformation, we have our traditional approach and a new approach that we are experimenting with. Let's take this statement. In this statement, we are basically saying that every time you find in the RPG abstract syntax tree a statement that is an invocation of a subroutine, in the Java abstract syntax tree you will put instead, as a translation of that bit of the RPG abstract syntax tree, a Java expression statement that contains a method call to a method that will be called as the subroutine in RPG. That is because every subroutine in RPG will be translated in a Java method. So this is simple. Or, for example, every time we find an end subroutine statement, we just put a return. That's easy. But there are things that are a bit more difficult to translate, like the display statement has to be translated with a system out print line. Now, the system out print line can seem like a very easy piece of code, but if you look at the abstract syntax tree, this is actually, well, first of all, is an expression statement that contains a method call to the method print line, and then there is, here I call it container, I could have called it context or whatever, but basically I have to specify the system out part, which is an access to the field out of something called system. And then I have to specify the arguments. So sometimes when translating things, I have to write manually cumbersome pieces of the abstract syntax tree. So an alternative that we are trying is transformation by example. And so we, for example, the display statement is translated in this way. You shouldn't think for a moment that we are just trying to look for those strings in the file. What we are trying to do is parsing these two examples building the abstract syntax tree using modified parser that can support also these placeholders. And so basically, when parsing this RPG example, we get an abstract syntax tree that we can use as a model, and when we find a similar piece in the abstract syntax tree of the file that we want to translate, we translate it with this part. And this part has placeholder because I want to specify this behavior every time that I'm trying to display anything. Maybe, if the expression that I could be using could be 1 plus 2, could be a string literal, could be the result to another call, and so on. So I want that to be generic, and this is why we are using the placeholder. So basically we are saying, when you are trying to display something, write system out print line, and then translate that something. So this is how we do. This is new, so we are experimenting with this. It has pros and cons because certain things are, you will need to provide an extremely high number of examples in certain cases. But for things like the display, it works well. Then, once we have obtained the... Okay, today I cannot remember my shortcuts. Once we have obtained the abstract syntax tree of Java, we need to print it. To print it, we use something very simple. We specify how to print the different kind of different pieces of the abstract syntax tree. For example, and this is just a demo, so this is a simplified printer for Java. When we find a field declaration, we are printing the type, the name, and if there is an initialization value, we print equal, and then we will call the printer for the expression specified as an initialization value. So here I could have any arbitrary expression, like, I don't know, 2 multiplied by 3 plus 2, and so the corresponding printer will be called and will be combined. And we have support for things like indentation, de-indentation, printing lists with separators, and so on. The printer part, honestly, is quite simple. I think the transformation part is the one that is a bit less intuitive, let's say. Now, I seem to have lost my slides. Okay, so just to review this overview of how to build a transpiler, the core part is the transformation, and the transformation could be specified by basically saying, when you encounter a node of this type, this is the AST that you need to build in the target language. Like here, for example, we are building manually the piece of Java AST to represent a sum between two values. We are working on this approach that basically avoid you to write the AST manually, because you give to it some examples and it parse this example, obtain the abstract syntax tree, and does what we have seen before without the need for us to write the AST manually. Then we have printers. Then we've seen basically specify how to take the information contained in the abstract syntax tree and put it back into a string. And all these features can be implemented using one of the library of Starlazo. So you can basically redo the same thing in Kotlin, in Typescript, in Python, and in C#. We have used this approach of writing all sorts of parsers, so we are confident that it works with all the languages that we encountered so far. And there are a gazillion things we didn't discuss, like, for example, how to test this translation or how to implement the runtime. So the code that you have to use together with your transpile code to have the whole system. For example, to replace the built-in functions that were present in the original program and they are not present in the target program. Now, I am about to conclude, so we will have time for questions. And these are a few resources, so some preliminary documentation of Starlazu that you can take a look at. And as I say, this library are all open source. Some articles on an article on how to write a transpiler, so explaining in more details what we've seen today. And if you also want to build your own parser, there is also a tutorial for writing the parser. So in case you're interested, you can find the links here. And that's it. So if you have questions, here I am. But I was so precise that there are no questions.
What about sorry. Thanks. What about the quality of the generated code? I mean, I assume that the generated code will be, formally correct, but probably not, at least not idiomatic for the target language, or you may want to improve something, you may want to refactor something, there is some other automatic tool that you can use, or you have a manual phase when you do these adjustments. I don't know.
That's a very good question, and I think what you can do are two things. The first one, you could, for example, refactor it after using IDEA, that is a better tool than the editor available for RPG. But the other thing that you could do is this, that is a bit more complicated, but if you're writing a transpiler for a specific company, a specific code base, what you can try to do is to analyze the patterns they're using and try to not translate elements by elements, but try to understand that certain elements put together represent something that you could better translate. A very stupid example. If I was translating Java into Kotlin, I could say, oh, here there is a getter, here there is a setter, here there is a field. These elements combine represent a property, so if I'm translating to a language a support property, I will translate it in that way. These things is generally much more difficult because you need to find patterns in the code, so this pattern is relatively simple, but this is also how, for example, we translate things that have not a corresponding translation in the target language. For example, GoTo. If I'm translating from a language that contains GoTo to a language that doesn't contain GoTo, I just cannot do that. But if I can say, okay, the GoTo here is used in this specific way, so it's basically the equivalent of an if, is the equivalent of a while loop. So that's something you could do and could lead to code that is more idiomatic, because in a way it's like you are not translating bit by bit, but understanding the intention to some extent, and you are translating that into an idiomatic way. It's much easier to say that than to do that, but that's what you can strive for if you're using software that has been built, a transpiler that has been built specifically for one code base and not a generic transpiler that cannot do that.
Thank you.
You kind of mentioned this at the end, that there was maybe no time to go into this, but I'm actually very curious about testing, meaning you have a customer with a large code base, you transpile it, it's Kotlin or whatever. How do you prove to this customer that the semantics have not changed? Whatever you got before, you can expect the same result from the new one.
I think that real-life testing will need to involve a lot the client, because the client knows the system. I mean, of course, we can have a test that check the translation of single statements. We can write little programs in RPG. For example, if you are translating from RPG, and little programs in Java, invoke them with a bunch of inputs and see the result. And this gives us some confidence. Then I would say end-to-end testing involving maybe, I mean, a lot of these applications have different moving parts, so maybe you want to, I don't know, spin a database, insert some data, run the program, and then check that the database is in the state you want. But this is very challenging, and I'm not saying that you press a button, it works, we are done, just send us the check. And I mean, it takes time because it's difficult to test them, and in reality, what I've seen is that people, for any application that is large, they decompose it, they start to isolate a little bit and maybe the bit and try to translate that with these end-to-end tests, and it's I would like to have a better answer, but
I understand. Thank you very much.
Thank you for the talk. I have a question about the tailored transpilers that you were talking about. So, I guess that in order to do something like that, it decreases the reusability of the transpiler, and also you need to have more insight on the code you're transpiling, right? Maybe even the semantics of the code. So, is it still convenient to do so if you go that far, or at that point? I mean, you took a lot of time to understand the original code, and maybe you can just rewrite it. Is it still convenient to go meta and have a program that rewrites your program?
That's a very good question. I mean, if you're trying to write a transpiler to translate, I don't know, 10,000 lines, don't do that. Just write your code. I mean, I should say that maybe some dysfunctional organization would prefer for someone else to write the transpiler because it will take them years to write even 10,000 lines of code. But there are cases in which you want to translate 30 million lines of code. But even in those cases, I think you want to have an automatic translation that reaches a certain point. That could be 90%, could be 98%, but at a certain point you have a diminishing return on your investment. So yeah, I wouldn't advise to say to translate always 100% of the code, because this is not realistic and you overcomplicate the transpiler. Or if you try to find a solution that is too generic, maybe it leads to code that is terrible for the common cases, and you also don't want that.
I see.
And just one thing on the tailoring the solution, I think it's important, because saying that I want to translate to Java or to Python, to me doesn't say much, because maybe I want to translate to Java, but I also want to use a certain framework, or the same things for Python, and I want to use a certain idioms, and so I think it's important that you can customize the transpiler based on the architecture, the culture, and the choice made at the company. Otherwise, you get code that is over generic, that is terrible, and yeah, it's not great.
Thank you.
And in case you have more questions later, you can find me around. Thank you.